the top of page 253, the we do. So we're going to take the idea of what is proper scientific notation and work with the metric prefixes on table C. So here we go. So the first thing that we're going to do is to go from a measurement that is measured in a unit that has a base and a prefix, and then just change it back to the base unit. No prefix symbol present. So when I take a look at this, it says 2,511. So those are the digits I'm going to write down. But it says kg. The K comes from table C because that's a prefix. And the G, that is the base unit. And we'll see that listed on table D. And when you put kg together, in this case, the quantity that they are representing is mass. So what I do is for the prefix K, I go to table C. I see that K stands for kilo, and its power of 10 is 10 raised to the third power. So now I've taken the kilo part out and replaced it with its power of 10, and I still have a unit of grams. When I take a look at the next number, I see that it has this MS, okay? And so MS, so when I'm thinking, I know that on table C, there are 3 prefixes that start with the letter M. There's mega, milli, and micro. So I have to pay attention here that M is a lowercase m. So that's my prefix. So it's not mega, it's not micro, it's milli. And S, in case I'm not sure what it is, that's my base unit. I can find it on table D. So when I look at prefix, lowercase m is milli, and according to table D, S is seconds. So this would read milliseconds. And if we're measuring something in seconds or milliseconds, we are measuring the quantity of time. It's a way to represent time. So to do this, I'm going to just take this number, I'm going to leave it, point, and then my 4 zeros, followed by the 5, 2, and then I'm going to replace the prefix, the milli, with its power of 10. Milli means 10 to the minus 3. So I have 0.000052 times 10 to the minus 3, and now it's in seconds. I take a look at this next one. It's 23 million NLs. Well, the first letter in this unit is the prefix, so I can find that on table C. And L, if I'm not sure what it is the base unit, so I can find its name on table D. So table C, N is nano, and L stands for liters, so this would be nanoliters. And whether it's regular liters or nanoliters, the quantity that's being expressed here is volume. So now I'm going to re-express this number by replacing the prefix letter N with its power of 10. So I still have 23 million. But now instead of N for nano, I replace it with its power of 10. 10 to the minus 9, and the unit, the base unit, is still present, liters. My next example is 0.015 mgs. So once again, I got to think through the process. I have 3 prefixes that start with the letter M. There's mega, milli, and micro, so I have to pay attention to the details. So when I look at the way that M is written, it's a capital M. So my prefix that uses a symbol of capital M is mega. The lowercase g is my base unit that I can find on table D, and that's grams. So this is megagrams. And if I'm measuring anything in megagrams, I am measuring what the base unit represents, a unit for mass. So to write this, I'm going to keep the 0.015, but now I'm going to replace the mega with its power of 10. And if it's mega, it means 10 raised to the 6th power. And so I still have a unit, base unit of grams. Last example, I have 865 weird looking U and L. So the weird looking U is a symbol that I will find on table C because it's a metric prefix. And the only one that has a symbol that looks like a funny looking U is micro. The capital L is the base unit for liters, so microliters. And anytime we're measuring anything in liters, with or without the prefix, we are representing the quantity of volume. So we have 865 microliters. So take a look. I keep my digits, 865, and now I've replaced that micro symbol with its power of 10. So 10 raised to the minus 6 power, and it's still in the base unit of liters. So we just simply replaced the prefix symbol with its power of 10 value. That's step 1. Step 2 is we need to put it into proper scientific notation. So proper scientific notation, the first thing is getting that coefficient correct. So that coefficient, it needs to be at least 1, and it maxes out at 9.99 to infinity. So the value of the coefficient at least 1, but less than 10. So when I take a look at the numbers, okay, the 52511, they're all non-zero digits, so they're all significant. So they all need to be shown in the coefficient. So my coefficient would be written as 2.511 times 10 to some power grams. I'm going to worry about the exponent a little bit later. The next one is I have all of these digits, but these, when I look at the number left and moving to the right, the first digits I see are zeros. Those zeros are leading. Leading zeros are never significant, so my first non-zero digit is the 5, and anything else to the right, these are the sig figs. So those are the only digits that I will see in the coefficient. So instead of having 0.000052, I simply rewrite it as 5.2 times 10, I'll figure out the exponent, seconds. Looking at the one that's 23 million, the way that this is written, to the right of the 23, we have 6 trailing zeros. There is no decimal point to the right of those zeros or anywhere in there. So these trailing zeros are not significant because there's no decimal. So the only significant digits are the 2 and 3. They are the only ones that can be found in that coefficient. So the new coefficient is 2.3 times 10, and it's raised to an exponent value that we'll figure out, liters. Moving on to the next example, we have 0.015. We have 2 leading zeros, never significant. So these digits here are the only ones that are allowed to be in the coefficient. So we have 1.5, because that fits within our range, times 10 grams. And our last example, all the digits showing 865, they're all non-zero digits, so they're all considered significant, so all of them need to be in our coefficient. So we'll write it as 8.65 times 10 to some power liters. Okay, so now our job here is to now figure out, because we moved the decimal point from where it was shown in the original to its new position to show a proper coefficient. So if we move the decimal, we have to adjust the exponent. So take a look. So I'm going to go here. This exponent says, hey, move, because it's positive, move to the right. But to get the decimal point sandwiched between the 2 and the 5, I had to move my decimal within the coefficient to the left. So they are moving opposite. So that means that I'm moving away from 0. So I will see an increase in the exponent value. So I'm already 3 moves away from 0. And each time I move, that's one more spot. So I'm starting off 3 from 0. Now 4 from 0, 5 from 0, 6 from 0. So my new exponent is 6. Taking a look at the next one, I have an exponent of 3. So I have 3 moves, but it's negative. So this exponent wants me to move to the left. Looking at where the decimal point started and to where it ends up in the coefficient, I moved the decimal to the right. So my arrows are moving in opposite directions. And so because of that, I'm going to be moving farther away. I'm already 3 moves from 0. Now I'm going to move farther away from it. So I'm going to see an increase in my exponent's magnitude value, the exponent's value. So I'm already 3 away. So every time I move this decimal point to be sandwiched between the 5 and 2, that's one more position farther away. So I'm already at 3. So now 4, 5, 6, 7, 8. So my new exponent value is 8, but I have to keep that minus sign to show, hey, it's 8 moves to the left. So it's a negative 8 exponent. Moving on to the next one, my exponent value is 9. So it means I have 9 moves with a decimal point, but it's negative, so that's the direction. Move it to the left. And to get where I understand the decimal to be, to where it is in the proper coefficient, I had to move it also to the left. So now my arrows are moving together. They're not opposite, they're moving in the same direction. So I'm just going to write same. So I have 9 moves to the left, but to get it sandwiched between the 2 and 3, how many of the 9 moves did I use? So 1, 2, 3, 4, 5, 6, 7. I had 9 moves. I used 7 of them. So that means I have 2 moves left. So my new exponent is 2, but my 2 moves that remain are still to the left. So I make it a negative 2. Keep going with the arrow analysis. Talk yourself through it. So my next value, its exponent is 6, meaning I can move this decimal 6 times. And because it's positive, it wants me to move the decimal 6 moves to the right. Taking a look to where my decimal started to its new position in the proper coefficient, I had to move it to the right also. So my arrows are moving together. They're going in the same direction. So the exponent says, hey, move 6 to the right, but my correction to the coefficient didn't use all 6. It only used 2. So I have 6 moves, but I only used 2. So how many remain? I have 4 moves remaining. So when your arrows, what the exponent tells you to do versus the direction, how you move the decimal to correct the coefficient when they move in the same direction, then you're going to see a decrease in the exponent's value because you're heading towards 0. Last example, exponent is 6. I can move the decimal 6 positions, but that negative sign tells me, hey, move it to the left. I had a value of the coefficient 865. To make it 8.65, I had to move the decimal in the coefficient to the left. So my arrow analysis tells me, hey, the exponent wants to move to the left. My correction made me move to the left. They're moving in the same direction. So I'm going to see a decrease in the exponent value. My new exponent value is going to be closer to 0. So I'm at 6, and when I move the decimal to the left of the 5, I used up one of the 6. So now I'm at 5. And when I move it one more time around the 6 to sandwich between the 8, I used up another move. So I used 2 moves. So I started off with 6. I used 2 moves to get it sandwiched between the 8 and the 6. So now I have 4 moves remaining. But I want to keep the moves continuing to the left. So I need to make this 4 a negative, because that negative sign says, hey, move the decimal left. So now you try the you do problems at the bottom of page 253. Make sure you check your work with me and ask for clarification if you're still struggling with how to correct your scientific notation.